Find players with 0 or 1 losses. You are given an integer array matches, where matches of I is equal to winner's I, loser I. Indicates that the player winner I defeated player loser I in a match. Return a list answer of size 2, where the answer of 0 is a list of all players that have not lost any matches, and answer of 1 is a list of all players that have lost exactly 1 match. The values in the two lists should be returning in increasing order. Note, you should only consider the players that have played at least 1 match, and the test cases will be generated such that no 2 matches will have the same outcome. Okay, so let's take a look at this input and see how we get to this output, right? So here we have an input array matches. It's an array inside of an array. Okay, it's a 2D array. So we have 1, 3. So each of these arrays represent an individual match that was played, and the first element in the array is the winner, is the number of the winner, and then the second element is the number of the loser. So 1 beat 3, 2 beat 3, 3 beat 6, etc. And in our output, our first array here is going to be the array of people that have not lost any matches. So they would never appear here in this in the second element of any of these arrays. So like, for example, we have 1 here. So player 1, we take a look at all these arrays, we'll notice that player 1 never appeared in this second element here. Same with player 2, same with player 10. And this second array here is all the players that have lost exactly 1 match. So they'd appear, once in this second element here in this array. They would have appeared once. 3 appeared twice, that's why 3 is not in here. So I think you get the point. Okay, so how are we going to do this? To do this, we're actually going to make use of both a set and a hash map. That's how I'm going to do it, at least. So we're going to have a hash map that basically is going to first initially count all the losers, basically. It's going to count all these elements, and we're going to see how many times the elements have appeared here, or how many times each player has lost. Okay? That's what the hash map's going to do. It's going to keep track of how many times each player has lost. And then we're going to have a set of every single player that exists, because we're only going to consider players that have played at least 1 match. So how are we going to know that? Okay, we're going to create a set. So everyone's going to be unique, right? It's like, it doesn't really matter. We don't care how many times the players won or lost. We just want a count of all the players that have competed. So they would have played at least once in here, right? So it's actually just going to be 1 to 10 pretty much, but Okay, so what we're going to do though is, how are we going to get the answers, right? So to get the array of players that have not lost any matches, what we're going to do is we're going to take all of the players, and we're going to run through the hash map afterwards. After we compute the hash map, we're going to have another loop where we just run through the hash map, and any player that appears inside of our hash map will be removed from the set of all players. And that will give us the answer of all players that never lost any matches. So, and the second array, to get all the players that have lost exactly 1 match, it's a lot easier. We can literally just look at the hash map and just look at all the players that have lost literally only once. They're the key value pair, their value would only be 1. So, okay, let's make this actually. Let's code it out. Should be pretty simple. Okay, we have all players. So we have a set of all players, and then we have losers, which is I'm gonna use default dict. Just convenient. So basically we're gonna go for I in matches. Here's what we're gonna do. Okay, so we're gonna loop through matches, and we're gonna add to the losers dict. Sorry, losers of I of 1. Okay, plus equals to 1. So here we're gonna, in the losers dictionary, or as we loop through matches, we're gonna take, instead of I, why don't we make this array? That would be a little cleaner. Every individual array, the second element or element number 1 is gonna be the loser. So we're gonna add 1 every time they lost. Okay, and we're also gonna compute all players here. So we're just pretty much going to all players dot add array of 0. So array of 0 would get the first player in the array, because we want every player that's at least played 1 match. So winning and losing, we want both of them. Okay, so this would get everyone. And our second loop, basically what it's going to do is going to be for key in losers. Okay, what we're going to do is if losers of key is equal to 1. So basically what that's doing is if the value, so if they've lost only once, okay, here's what we're going to do. We're also going to have a losers array, right? We're going to have a losers array. If they've lost only once, we're going to add to losers array. So losers array dot append, just going to append that person. And then we're also going to subtract from all players. So all players dot maybe delete or dot remove maybe. Well, we're going to find out if this is correct or not, but dot remove key. And what we're going to do is we have to now sort it, because they said that the values in the toolist should be returned in increasing order. Okay, so here's how that's going to look. So we have losers array first. So let's get that sorted, right? So losers array dot sort, pretty much that'll sort that in place. And then we want so for losers array, or let's call this, let's not call this losers array, let's call this one loss dot append the key. Let's be more specific. Okay, one loss all players, so if they've lost once, so one loss dot sort. Okay, no losses is going to be equal to sorted. Or wait, which one is in place? Sort is in place, and I think sorted returns something. So if sorted returns something, then this would be list of all players, I guess. List all players. Okay, and we would return an array that has first no losses, and then we have one loss, and we would return that array, and we would get our answer. Okay, perfect. Okay, so what's the runtime complexity gonna be? Well, we would have for array in matches, since we'd be looping through the entirety of matches, which is our input, we'd have O of n. And then inside of matches, since we'd be looping through each array inside of matches, we could call that m, so it would be like O of n plus m. All right, and then our spacetime complexity, or our extra space here, would be all players, which is a set that includes every single player that we see. We could call that, like, technically it's not the entire array, but I guess we call that like O of k. But we're also going to create a losers with default dict, and that's going to pretty much go through each individual array inside matches, and add to the losers. So that's definitely O of n. So like maybe O of n plus k. Not 100% sure. Okay, let's actually double check that. Let's see exactly what it is. Let's see. Let's figure it out. Can I see what our complexity is? Space time, or space and runtime complexity. Well, don't know. Maybe solution? Maybe that's how I do it. Well, let's take a look here. Oh, well, let's ask Leet. What is the space and runtime complexity of my code? Yeah, sure. Take a look. My code here. Sure has given us this O of n. And okay. For time complexity, consider first loop. Okay. How many times does this iterate? What's the cost? So this first loop is definitely O of n. Second loop. Okay, so for key and losers, which is pretty much still the length of matches, kind of. We consider individual arrays. Maybe M? Don't know what you'd call that. Sorting operations, you have one last dot sort. Oh, I forgot about that. Okay. So O of k for that, for both of those. And if n equals length matches and p is equal number of unique players, okay, O of n plus p maybe. For space with data structures, so if p is players, then like, this is definitely O of p here. And then losers is like just the losers. So an O of L. It's not even O of P, man. Structure. Okay. I got O of N plus P runtime and O of P space. O of N plus P log N. And track your runtime you correctly address. Consider the sorting operation. Dot sort k elements. Can't see what that says. Okay. Sort m elements. What's the time complexity of sorting in Python? Okay. What's the time complexity of sorting in Python? Well, of a normal sort, maybe like login, or let's see, log n. We definitely know it's O of n, p log n space time. Don't know. Or runtime complexity is what I meant. Full runtime. Okay, it's telling me exactly what it's thinking. Dude, leetcode. LeetCode AI is interesting. Code AI is very interesting. Huh. You know, I think I'll end the video there. Okay. So maximum number is P is 2n O of P log P. O of P log P. Okay guys, it's O of P log P is runtime, or the sorting part. Okay. O of N. Okay, so what's the final complexity just for the sorting part? Let's see. N plus P log P. That's what I thought. O of N plus P log P. Well, that's the answer, guys. It's O of N plus P log P. Okay. That's the answer. See ya.